Hi, everybody. I'm Jeremy Berkoff, co-founder of eSonic and former CTO of Supersonic Imaging. In the last 20 years, there have been two technological trends in the ultrasound industry. The first one is miniaturization, with the advent of handheld probes that can be plugged to a tablet or a smartphone. They have today very acceptable clinical performance and are becoming a must-have in the point-of-care market. The second trend is ultra-fast imaging. Targeted to our high-end and premium markets today, this technology opens new frontier in ultrasound application and performances. Ultra-fast imaging is defined as the capacity to image the body at several thousands of images per second. This is 20 to 100 times faster than conventional ultrasound. When you look at things at an ultra-fast frame rate, we see a lot more details than the human eye can ever catch. And inside the body, physiological phenomena can be imaged and analyzed with a much finer detail and resolution, leading to new diagnostic information and much better accuracy. We can, for example, map tissue stiffness quantitatively. This is the E-mode developed on eSonic premium system. It allows real-time and quantitative visualization of tissue stiffness. This is not possible without ultra-fast imaging. This is a concrete example of a new capacity of an ultrasound system that brings new diagnostic capabilities: cancer characterization, fat liver assessment, musculoskeletal or cardiac disease diagnostic. We can also image blood flow with much better sensitivity. And recently, researchers in Paris have shown extraordinary maps of brain activation in real time. This is the microvascularization of a brain rat when stimulating the whiskers. Jacques will show you next in the presentation a few other examples on how ultra-fast imaging can be leveraged to find new clinical information. And there are many. Ultra-fast imaging has been investigated in research laboratories since the late 90s. I personally defended my PhD thesis in 2004 on ultra-fast imaging and its application to shear wave elastography. With Jacques, we introduced the Explorer, the first commercial ultra-fast ultrasound system in the world, in 2009. And I can tell you that building an ultra-fast system is a real paradigm shift from an engineering and technological standpoint. You cannot rely on conventional methods that ultrasound has been used since the 70s. In conventional ultrasound, images are built sequentially, beam by beam, line by line. In ultrafast, the way ultrasound is sent in the body needs to be redefined. The way ultrasound data is acquired and processed needs to be reinvented. You need a full parallelized system capable of computing the full image for each transmit at several thousand of images per second. Not all manufacturers have been successful in making the move because the technological gap is huge. eSonic is leading this technological revolution in China. In the future, with the exponential increase in processing power, ultra-fast imaging will become an even more stronger differentiator in the ultrasound. 3D, 4D imaging with matrix arrays will become the standard on premium system, and ultra-fast technology will allow performing 4D imaging with much faster frame rate and much better performance in competition. And eSonic talented team will be leading this journey. Thank you very much.